Within all this, we just need to take account of the role, particularly of a key enzyme, which is lactate dehydrogenase. Now, lactate dehydrogenase is actually comes in two forms. LDH1 is associated with the formation of lactate, and LDH2 favours the conversion of lactate to pyruvate. Now, this is really important. Although we can talk about lactate dehydrogenase as being a fundamental component within lactate production, there are actually these two types. And what we know is that LDH activity is lower in type 1 fibres compared to type 2, but the contribution from LDH2 is higher in type 1 than in type 2 fibres. Now, what we know is actually these have two distinct names. We have what is called muscle-specific and heart-specific LDH, and it's pretty obvious which is which. Muscle-specific is generally referred to as LDH1. Heart-specific is generally referred to as LDH2. It's not that they are just associated with the muscle and the heart, it's just that there is a predominance of LDH2 in the heart, there's a predominance of LDH1 in skeletal muscle. Both exist. Remember, the heart isn't going to really, in a healthy condition, produce lactate. Okay, you don't want lactate being produced in the heart. So the heart actually can be a consumer of lactate, so it's going to be rich in LDH2. Whereas in our skeletal muscles, we understand that there's more LDH activity in type 2, but it's much more, LDH2 is much higher in type 1 than type 2. Why? Type 1 fibres, remember, they're MCT1 rich, which means they're good for disappearance because they want to convert lactate back to pyruvate. They're mitochondrial rich. Therefore, they're going to be associated with the conversion of lactate back to pyruvate, LDH2. And again, we understand that lactate dehydrogenase increases, the concentration increases in response to endurance-based exercise. And so the simple answer is yes. Could there be an association between the training state of lactate dehydrogenase levels and the use of lactate as a mitochondrial fuel? Yes, absolutely. So if you expose somebody to an endurance training program, we know that there is an increase in lactate dehydrogenase. We know, as we saw previously, there is a decrease in lactate, blood lactate concentration, primarily because you've got a decrease in the rate of appearance, but coupled with that, the lactate that is being produced and enters the circulation can be taken up at the inactive fibres, because they're going ideally the slow twitching active fibres that are MCT1 rich, they're mitochondrial density rich, and because endurance training increases lactate dehydrogenase, then the lactate is converted nicely back to pyruvate. The final thing is, mentioned earlier on from Bangsbo, that it's about 50 to 90% of lactate transport occurs using the MCTs. There is a proportion of lactate that is actually carried on the red blood cell, and we certainly know that this is population specific, and we know that the red blood cell plays an enormous part in this, and this is linked in part to oxygen dissociation curves. But we understand actually that there was some nice work done by Al Said, who is based at Liverpool John Moores University. And what Al Said was able to show was in groups of animals, there were animals which were predominantly lactate producers and animals which were predominantly lactate consumers, and they were able to show how much of the lactate was taken up on the red blood cell. And they found that when they compared 4 groups of animals, which was the dog, the horse, the goat and the cow, well, the cow is predominantly, one would, not surprisingly, if you think about the way the cow meanders around, a low intensity exercise or a low intensity individual, so its ability to produce lactate is quite low, but its ability to get lactate disappearance is quite poor. So it doesn't produce much lactate, but any lactate it does produce, it doesn't get good clearance of. Where you think about something like the dog produces a lot of lactate, but it can cope with the lactate concentrations under low intensity conditions, but under high intensity conditions, but less well under low intensity conditions, whereas the cow is the reverse. In other words, there are population specifics, and this is very much related to fibre types, but it's also related to their ability to take up the lactate, not using MCTs, but using the red blood cell. And if you think about it, which is more aerobically developed, well, the cow actually is a very aerobically developed animal. You think about the dog does a lot of short spurt activity, so it's perhaps more anaerobically developed, so it's more accustomed to lactate production than it is to lactate removal. So it just hints that there is another transport mechanism for lactate other than the MCTs.